Application of Euclid's division lemma. Example. Use the Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Solution. We first write the Euclid's division lemma as shown here. Now let us take any two positive integers, say a and b, and take the value of b as 3. We have taken b as 3 because in the question 3m or 3m plus 1 is given. Now a is equal to 3q plus r for some integer q is greater than or equal to 0. Now r is equal to 0, 1 or 2 because r is greater than or equal to 0 but less than 3. That means the remainder is either 0, 1 or 2. If we divide it by 3, then the remainder can never be 3. So a is equal to 3q or 3q plus 1 or 3q plus 2. Now let's take the square of it and we get a square is equal to 3q whole square, 3q plus 1 whole square and 3q plus 2 whole square. So a square becomes 9q square, 9q square plus 6q plus 1 and 9q square plus 12q plus 4. Let's simplify this further and we get this now. We can represent a square as 3k1, 3k2 plus 1 and 3k3 plus 1, where k1, k2 and k3 are some positive integers. So we can say that the square of any positive integer is either of the form 3m or 3m plus 1.